right, let's get started. So today, when you want to know about the health and welfare and performance of any of your applications or infrastructure or compute environment, we don't say monitoring. That's an old term. Instead, we say observability. We've said that word a lot over the last 2 days. But the problem, so I like the word observability. It's got power, it's got weight, it's got gravitas. The problem is I'm old. So back in my day, my back hurts just saying that. Back in my day, we didn't have this newfangled observability stuff. Instead, now, I'm not saying that we had to smack rocks together and listen for ping responses, but what I'm saying is that what we lacked was a direct understanding of the user's experience. In this picture, up in the boat above the water, that's the users, right? We didn't have any of that. What we had was metrics and events and logs that were buried deep inside file systems on the computer, and we had to infer the user's experience from what was happening up above. We had things like OS performance metrics, and we had really badly written queries that we could run. And that was me, the sysadmin, with like a bash script and a SSH session and stuff like that. Of course, there was the dev with his head above water, not realizing there were sharks circling. He thought everything was fine. It's always DNS. Like, it's always DNS. That one, it'll get you. But then down there, down in the murky bottom, that's where the network stuff was. And that was where the good stuff could be found. And then we got distributed tracing. And we didn't know it was possible, but once we saw it, we knew we needed to have it in our life. Tracing told us the thing that we'd always actually wanted to know, which was how real users were really experiencing our real environment at that moment. But somewhere along the way, we got so dazzled by the gorgeousness of traces that we lost track of the network. But the truth is that unless you won't fully understand your application's health and performance unless and until you understand the network side of it. Now, this talk today is to help you discover, or in some cases rediscover, the joy of network monitoring. It is not a rant about how it's never the network, although it's never the network. And it's also not a rant about the things that we network engineers wish developers would learn, although my God, please. Subnetting is a thing still. My goal instead is to share the modern useful value that network and monitoring and observability has, and to show how that data can enhance and inform your other sources of insight. So, thank you for joining me today to talk about network observability. It is an area of technology that has been consistently overlooked, underappreciated, and in light of some of the outages we saw this week, more important than ever. My name is Adato. Nothing on this slide matters because I'm yet another white dude at a conference giving a talk. I don't care about the rest of it, except I did pick that picture so that you would feel confident that I know what the hell I'm talking about. And also you can find me as Adato on all social media. More important, I want you to understand this is an oyster talk. Now, what I mean by that is that I have 30 minutes. I cannot teach you anything in 30 minutes. In 30 minutes, the only thing I'm able to do is irritate you. Now, the reason I call this an oyster talk is because when an oyster gets irritated, it has a choice. It can create a beautiful pearl, or it can die. I sincerely hope I do not irritate you to death, but there is a choice, and I thought it was friendly to warn you about it. Instead, I hope that I give you just a grain of an idea, which you will then take and layer with your own ideas and experiences until what you have is something that is polished and unique and personal and valuable to you. Okay, for many tech practitioners, they think that network monitoring, the idea of monitoring the network, starts and ends with ping. Or worse, they think it looks like this. This is a Wireshark capture of packets. I am here to tell you that if this was the best that network monitoring had to offer, nobody in this room, myself included, would ever want to have anything to do with the freak show that is trying to dive through these things. Instead, I want to show you that network monitoring and observability is way more than that. Okay, I have used the O word multiple times now, as we have throughout, so I'm going to put my spin on what this means. I'm about to draw a line on the slide. There it is. And I do so with the utmost respect for the people who lost their minds and their hairlining in the Twitter flame wars of a few years of what is observability. I'm not trying to totally define observability for everybody. I'm simply trying to give context for the conversation we're having here today. So my definitions about monitoring versus observability for the context of network monitoring observability. First of all, monitoring deals with the known unknowns. We know what shit can break, we just don't know when. Monitoring also tends to care about any cardinality. I don't care how unique or not unique it is. I simply want to know that it happens. I'm not worried about only the most super rare events. Monitoring is also mostly manual. Humans have to have a model of the application and know that when latency increases and the number of users on the system and this query responds slowly, I have to know that myself to create an effective trigger. That's, again, a monitoring context. And finally, the signals, the things that tell me that something is healthy or not, are mostly domain specific, because the things that tell me my storage array are bad are definitively different than the things that tell me my Wi-Fi is not working well or that my code is executing poorly, okay? On the other side of the slide, observability tends, again, I'm not trying to make like a global thing. I don't want charity majors to come here and eviscerate me on the spot. Observability tends to care about the unknown unknowns. We don't know what's going to go wrong, and we don't know when it's going to go wrong. Also, high cardinality events tend to be more important in observability context, meaning the more unique something is, whether it's unique within a particular period of time or it's unique overall, like we've never seen this before, that is interesting in observability contexts. Because of that, and because observability tends to use what I very technically refer to as a metric ass ton of data, the correlation has to be baked into the system. You have to use computers to do it. Again, as Charity Majors and Liz Fong-Jones talk about, it's more data than a human can reason about. Now, as soon as I start to say the computers have to do it, immediately people talk about AI. The trouble is that when vendors say AI, it's typically a bullshit marketing term for 3 if statements and a trench coat. All right, now we all understand, especially after today, that AI is not completely bullshit, but I am telling you right now that if a vendor says AI and all it is a ragged up, if you don't speak French, then pretend I said ChatGPT, okay? But anyway, if it's just a ragged up ChatGPT, it's not the game changer that the vendor thinks it is, okay? It's more than just a chatbot. Okay, finally, anyway, joking about AI aside, finally, it tends to care about the golden signals, okay? Latency, traffic, errors, and saturation. These are signals or issues that will tell you generally how any kind of application or service is performing, whether it's good or bad. So these are the differentiators between monitoring observability in my humble opinion. Okay, back to network observability, the glorious world that is network observability. So this is the point, if I was a vendor and trying to sell you something, that I would start to build up a story, laying a foundation for a mind-blowing payoff. And I would probably start off by telling you about the history of the internet. And then I would tell you about the OSI model, the 7 layers, not the 10 layers with politics and money and religion. And I would probably go on a rant about SNMP and how amazing it is and it's not completely worthless anymore. I would probably do that, but you know what? Screw it. I'm going to go straight into what network observability looks like, and then we'll talk about how you get some, all right? So yeah, network observability tells you that things spiked. Absolutely, we need to know that. But it also tells you what that spike is made up of all the way through. Now I'm going to go into this side of it in detail in a little bit, but that is really the value of network observability, to understand that spike is made up of a lot of remote anything. Why the hell do I have remote anything running that much on my network? And oh, by the way, why is NetBIOS running at all? So that's one of the values right there. Yes, network observability is helpful to understand that your website is taking a really long time to load. 8 seconds. This is my daughter's bakery website, by the way. 8 seconds. And that's before any of the actual code starts to run. That is important. But network observability is being able to see something that's invisible to tracing and logs and metrics to see that an intermediate device somewhere along the way, this thing in Texas running on roadrunner.com, this is injecting latency all along the way. And more than that, I know this box over here is hard to see, so I'll make it bigger. I can actually call them and say, hey, what's up with your router? Interface 7 is really whacked right now. That is a thing that most quote-unquote observability tools don't really give you or don't give you easily. Speaking of where the network traffic is going, this is an image of what's called a trombone. Some people will call it a hairpin. I don't care what you call it. What it's showing up above here, but also is that the data leaves New York, it takes a vacation in Italy because who wouldn't want to, and then it comes back to land with the user in Boston. There is no network design I know of in which route the traffic from New York through Italy is the right design choice. And as we heard yesterday, it could violate data sovereignty laws as well. But network observability is a thing that will show you this, that will let you know where your data is going before it arrives. And also, I just need to point out, the internet is multipath. So both when you're looking at something like this and when you're looking at something like this, you're seeing all the paths that your data is taking, not just the one path, because there ain't one path. Again, if we look at this, you can see that there's 3 milliseconds of delay here, there's less than 1 millisecond of delay here, and so 21 milliseconds of delay here, and my data is going along these paths, all of them, at the same time, right now. If I wait a minute, that route will look completely different. And I need to know that, because when somebody calls and says, why was it slow 5 minutes ago? I don't know, 5 minutes ago is like forever. I can't tell you. But network observability tools will be able to show you and tell you exactly that. So yeah, network observability is about having the right tools. And traceroute is 100% the right tool to use until it fails. You've seen this before, right? Like just play. Those 3 stars are not like because it's a really good route. 3-star, no, it ain't responding. And the reason it's not responding happens almost immediately because anyone who's taken any kind of networking course ever knows that the first thing you shut off on a router as soon as someone lets you SSH into it is you turn off ICMP echoes. ICMP is ping. Echoes is what lets it respond. You immediately turn it off on every router, which means that ping and traceroute immediately stop working. Unless you're using Azure, in which case, you can't ping a damn thing. They shut off the entire ICMP protocol on the entire platform. Just to emphasize here, we asked them, like, can I ping this was our email. We asked them this question. No, you cannot ping anything on Azure. Good luck. So network observability is also about having better versions of the tools that we do rely on so that they do the same task, but they get around those limitations. So what we're looking at is 2 different implementations of a better traceroute. The first one is Pietrasanta, because you name your traceroute after where it was invented. That was the village where the developer lived. Pietrasanta, which can get around some of it. You can use different protocols. It doesn't use ICMP. That's one of them. The one that a lot of people know is MTR, which is not my traceroute. It's actually Matt's traceroute. That's the dev. And what's really cool about this, I didn't turn this into a GIF, is that it constantly refreshes. You're getting remember I said the internet is multipath and things change all the time? Matt's traceroute, or MTR, will refresh and tell you as those routes change constantly. So you can see that. So again, network observability is about having better versions of the tools that we use to find out how things are working. So at this point, hopefully you're intrigued, maybe a little excited. In my opinion, you should be. This stuff is really cool. But because I am a shitty marketer, because I'm not, I'm an engineer, I'm going to pour the cold water of reason all over your enthusiasm. Network observability, the best tool, the only tool, the one tool to bring them all in the traces, bind them. Like, it's not that, right? It is a tool. Network observability is also not application observability. Don't let anyone try to tell you it is. Application observability, so network observability enriches the data you have from application observability. It enhances it, but it doesn't replace it. Network observability is also not APM or IPM, a term that my company invented and keeps trying to make it be a thing. Anyway, they made me use the slide, but it's not either one of those things, all right? Once again, network observability, the network is part of these concepts. It feeds into it, but it's not the only part of it. Network observability is also not a management tool, and I see this happen a lot with monitoring and observability tools, is that you have a team that's responsible for fixing shit. I think people who are responsible for fixing something need to have the autonomy to pick the tools they use to fix it. And those tools often have monitoring capabilities built into them, and that's cool, but that's not a monitoring tool, because when I'm using my Cisco management tool, it ain't gonna help me with my F5s. So you have to be clear, and you have to help your leadership be clear that your management tools are not a replacement for your monitoring tools, and especially networking, because networking tends to be very specialized. You still need a broad tool that can handle the entire platform, or the entire environment. And honestly, I do work at vendors who sell monitoring and observability tools, and I'm here to tell you, I know that they try to tell you they're the only tool, they're the best tool, you can get rid of all your other tools. Do not believe them. And better still, try to work with your management to make sure they don't believe them either. You will all be very sad. Now, I'm going to be really transparent. I've been working with monitoring and observability tools for 27 years. And they still, to this day, continue to use the same handful of techniques, right? It's not like that special. It's not the the cold fusion that they make it sound like. Now, I'm not saying that every observability tool is the same. I'm not saying that just putting a different color lipstick on a pig, all right? My point is that the way they collect the data is not important or special or magical. What does differentiate your tools is the way that they, first of all, process the data, the way they pipeline it, the way they filter it, the way they manage the data and normalize it, and also how easy they make it to interact with that data in the form of alerts and dashboards and reports. And also, super important, how well they play with others. That's a differentiator. Are they able to take the data and pull it out and combine it with data from other tools so you can get a full picture of things? Because once again, no single tool, there is no one size fits all. There's not even a one size fits most. You are going to have multiple observability tools. Network observability is a piece of the puzzle. And so you're looking for tools that play well, like I said, play well with others and combine. Okay, so let's talk about these techniques. And we have pillars because, of course, we have pillars because we have to have pillars. All right? These are not the observability pillars, but these are the pillars that I'm using. We're going to start off with metric, network metrics specifically. Network-specific infrastructure uses the usual suspects. We've got ping over there, and we also have SNMP, and we have traceroute we talked about before. We have WMI because I was going to say it's not just for Windows, but let's be honest, it's just for Windows. But we still have WMI as a thing. And then we have the horror show that is screen scraping, that is also a technique. And I'm talking about screen scraping as a horror show, not the dog. She is a very good girl. Okay, but screen scraping, if you have a tool that does that, maybe consider a different career. I don't know. All right, but there's other things also. For example, APIs. Network observability includes APIs. There is a wide range of network, like route and switch infrastructure boxes, both in the cloud and on premises, that have a full RESTful API associated with them. And that opens up a lot of opportunities, both for monitoring and for automation. But if you're not aware of it, you're not looking for it, and you don't realize that you can get an enormous amount of data over, you think it's like a command line. You have to do that. No, it has an API. So then I want to make sure you're aware of that. That is also a network observability technique, a valid one. There's also streaming telemetry. Yes, it's only Cisco, but yes, it's becoming more and more prevalent and popular. What it does, for those people who've never heard of streaming telemetry, it combines the metrics, the type of metrics that you'll find in SNMP, but the push-based delivery model that you'd find in OpenTelemetry. And what you end up with, as we're showing here, is a much smoother set of data, because you're not just getting these spikes of every 15 minutes or every 5 minutes or whatever. You're getting this continuous flow of data, but without putting a load on the target device where you're constantly asking it SNMP get, are you okay? Are you okay? What's going on right now? Which is like a DDoS attack, just under a different name. So streaming telemetry is worth taking a look at also. Okay, metrics. Lots more, but it's a good start. All right, synthetic testing. Now, remember we talked about traces, right? If traces are like this, solid, alluring, They look amazing, whether they're all dressed up or just in the raw. Is it warm in here? I don't know. Anyway, synthetics are just like that, except not. They're to model, to mimic real user activity. Joking aside, they can open up an entire world of monitoring insights that you honestly can't get any other way. So yeah, synthetics, as we looked at before, will tell you how every single step of the load goes. That's wonderful. But you notice I've got a few APIs going on down at the bottom there, right? Now, those are the APIs that get hit when someone gets to my first website. But as we all know, there are APIs that are running constantly depending on what the user does. So what happens when you've got APIs that only get used when someone uses the fourth submenu of the fifth menu choice on a Tuesday or whatever it is? Synthetics will let you exercise every single API every 5 minutes, every hour, every day, whatever you want, and do exactly what you want and let you know when that API is not actually working before a user tries to move to a lesser used part of your application and trips over it. So synthetics can do that for you. Synthetics will also let you test CDNs. We heard about that earlier, right? Because when you're testing just the website, you are going through the CDN. But how do you know that is the fastest way? How do you know that using the CDN isn't actually slower than going to your site raw? Synthetics let you test both and compare them so that you can tell whether your CDN dollars are being well spent. Also, it will tell you whether users that are over on one side of the planet are using the correct CDN, the one that's close to them, or are they going clear across Europe and getting something from the other side? So synthetics will let you test that as well. And again, you can test it every 5 minutes, every hour, every whatever you want to do. But it works on my machine. It's maybe cute, but it's a tired old cliche. But it works for everyone in Switzerland is just insulting because it doesn't help everybody else. All right? But more than that, synthetics provide a systematic way to test a particular thing from multiple locations. And that's another thing that many people misunderstand. Synthetics is not, it's running from my machine, so it must be up. Synthetics isn't even, it's running from AWS, so it must be up. Because I'm here to tell you that 3 weeks ago, people who were monitoring the stuff that was in AWS from AWS, it was great. Except AWS wasn't available. So it wasn't going anywhere, right? You've got to be able to monitor from multiple locations. So as you're looking for a synthetic vendor, you want one that has many points of presence that you can run a test from so that you can test and know the performance of your application from where your users are. And that's because the internet actually is your application infrastructure. As sure as I am standing here talking to you today, there are parts of your application, your APIs, load balancers, databases, that are not in the same place that other parts of your application are. And that all the stuff that connects those parts, you don't own those. I guarantee you there are parts that you don't own. So the only way to understand how an actual user is really experiencing your stuff is with synthetics. And the reason why I say that, yes, I do know that real user monitoring, RUM, not the fun kind, the boring kind. The RUM exists. I know that tracing tells you what's happening. But the problem, as we've been hearing, is that the sheer volume of data to manage that is difficult in and of itself. You've got to do sampling. And therefore, to avoid the sampling and to really know how things are going, synthetics will let you test actual locations as often as you need, and you'll get all of that data and be certain that it's working. More importantly, synthetics are there and running when your users are asleep. At 2 o'clock in the morning, you can know that a service isn't running and fix it before they actually log in. Okay, the last pillar, network traffic analytics. I could not do it justice in the time I have left. I couldn't do it justice if you gave me the whole day. But we're going to cover a little bit of it. Network flow, which does include NetFlow, which was invented by Cisco, but there's also SFlow, sample flow, and JFlow, and IPFix, and a bunch of other formats also. So we're talking about flow, right? So flow takes the idea of how much bandwidth am I using, and it breaks it down or adds to it or enhances it by telling you source and destination, port, protocol, application also, and geography. Flow can tell you all of those things, both from where it's coming from and where it's going to. So yeah, regular network metrics, they tell you that things are spiking. Flow, as I showed you earlier, tells you what that spike is made up of. And everyone's eye is always drawn to the top talkers, right? The big blocks on the thing. I'm here to tell you that, especially when you talk about ports, you want to keep an eye for the bottom, because if it's using port 0, you are being hacked. Port 0 ain't a thing. Actually, I take it back. Port 0 is a thing if you're like trying to use NetFlow on ping and some really low-level stuff. But generally, when you see traffic, like a little trickle of traffic that's going to countries that are farther east of here than here, a little trickle of port 0 traffic, you've got a problem. So you want to also, so NetFlow or Flow allows you to have alerts and awareness of things like that you might not otherwise catch. It also tells you, as I was talking about, it tells you where the traffic originated, it tells you where it's going to, it tells you every stop of the way, all the way through, and how much of that US East traffic, because we're taking it out of these places, it's all being filtered through US East, which was a mistake 3 weeks ago, but okay, fine, lesson learned. And then it's going through these protocols and so on and so forth. Flow can break that down for you, and it can build a picture that, once again, traces, metrics, and logs can't. Now, I mentioned before that in 30 minutes, about the only thing I can do is irritate you. If you are feeling irritated right now, it might be time to take that grain of an idea and think about what ideas I've given you and create a pearl of your very own. Meanwhile, I am ready for your questions. Thank you very much.